Welcome to the channel. In this tutorial we're going to create a ground dry simulation. We'll use a sphere projection technique mixed with shape blending and fracturing. So let's jump into Houdini. Alright, let's create a new geometry node. And inside let's drop a grid node. And we're going to scatter some points on the surface. So let's set the total count to 100 maybe for now. And let's use a Voronoi fracture node, and let's use these generated points. And maybe let's deselect the create interior surfaces checkbox. Okay, now we can use a remesh node. We can leave the settings as they are for now, or maybe let's decrease the target size to 0.05 like this. And now let's add some displacement, because all the if we now use the exploded view, you can see that we have kind of straight edges on the seams, and we want to add more randomness to this. So the way we can do that is we can use a mountain sop, and inside here we can change the amplitude to maybe 0.2 and the element size to 1.35 maybe. I think it's okay. And now we can duplicate this node again, and here we can maybe change the element size to 0.6 to have, you know, more details like this. And now, as you can see, we don't want basically the offset on the y-axis. We want only the displacement to be on the z-x plane. So let's drop a wrangle, and inside the wrangle we are going to simply change the y position to 0. So now the surface is flat, but we have those we've displaced the edges already, so it's kind of cool. Oh, I forgot that in attribute noise you should change the range values to 0 centered also, if you haven't. Okay, so now we can drop another remesh node after this, and here maybe let's leave the settings as they are. We can delete the exploded view for now. And now let's use a for each loop for each connected piece. So we are going to iterate on every island. Let's make some place here. Yeah, and now let's start by snapping the object to the center, because for now, you know, it is on its own position. We need to move it to the center. So let's use a transform node, and here in the translate let's type $$ CEX for X component, $$ CEY for Y component, and $$ CEZ for Z component. So now it's in the middle of the space. And now we can drop a remesh node again, but this time let's change the target size to 0.1 maybe, like this. And after that we can drop a fuse node, and after the fuse node let's maybe organize it a little. And after the fuse node let's drop a scatter node again, and we're going to scatter 12 points for now. And again we can copy the Voronoi fracture node, and we can paste it here and connect these nodes like this. And so now basically we added like something like the secondary fracture. First we fractured the main grid, now we are fracturing every island separately. So It will add more details later. So now we can drop a wrangle node, and inside the wrangle let's create a new float attribute. Let's call it p length, and let's make it equal to the length of the position attribute viet p. Like this. And after that, if you go to the geometry spreadsheet, you can see that this is basically the magnitude of the position vector, and we want only to take the maximum value. So the way we are going to do this is we can drop an attribute promote node, and we are going to promote the p length attribute from point to detail, and as a promotion method we're going to choose the maximum value. So now if you go to geometry spreadsheet and you go to the detail, you can see that we have the maximum value of the magnitude of the position vector. So we're going to use this as a size of the sphere projection. So now we can maybe go and create another loop. So let's use a for each connected piece again. So we have a nested loop, one loop inside another, and here we are basically going to iterate over all of the islands of a single piece like this. And let's start by creating a ray node, but before this let's create a sphere like this maybe, and yeah, let's double it, so 26 rows and 48 columns. And now we want to transform this sphere so it's, you know, above the space plane. So let's type minus, maybe only for the y component, minus or $y max, like this. But we want to have a slightly we want to have a little offset here, so y max multiplied by 1.01 maybe, so it isn't at the 0 location. So now we can connect the transform to the second ray input, and if we display this, now you won't see any much of a difference, but we need to change the direction to vector, and let's delete the channels, and as a ray direction we are going to use the up vector, so one for the y component, and for the scale maybe let's use 0.8. And let's go back to the sphere, and here let's change the radius to 1 everywhere. So now you can see that we properly projected the piece to our sphere, and this way we're going to implement the bending actually for all of the islands. So now we can proceed, and let's maybe organize it a little like this. Maybe let's press Shift S if you like these connections to be more like this, and let's drop a poly extrude node, and inside this node let's change the distance to 0.05, so maybe like this for now, and let's check the output bug as well. And now we are ready to subdivide this, but let's change the algorithm to open subdiv bilinear like this, and let's now create a VDB from polygons, maybe 0.05 or I don't know, 0.01. And now we're ready to drop a VDB smooth node, maybe 3 for the iterations. And now we can convert this VDB to polygons. So VDB convert to polygons, like this. And now we can use another array node. So let's drop array, and we are going to project the original geometry to the smoother one. So in the array node, let's change the method to minimum distance, like this, and I think we can leave it for now. Now let's select the polyextrude and subdivide node, and let's create a reference copy from them, and let's connect the input of the loop here, like this. It's important to have the same values on these two nodes. And now we can drop a normal node here, so normal, and after that let's drop a wrangle node, and to this wrangle let's connect normal to the first input and this array node to the second one. Let's display it, and here we're going to create an attribute. Let's call it vector position transformed, maybe transformed, like this, and let's make it equal to position of the first input, like this. So now we can go ahead and create, let's maybe make a little space here. Let's place another wrangle node here, and let's update the position. So v at p plus equals, let's take the original position. So we need to create an assemble node, create packed geometry, so we have a point reference for our original position, and let's connect this to the second input of the second wrangle node, like this. So now v at p plus equals point attribute from first input. We are going to take position at point 0, like this. And now let's also update the position transformed attribute. So v at pose transformed plus equals, we can copy and paste this actually this way. So now you can see the difference that previously it was at the center, now it's near the original position, like this. So now let's I think we can close the loop. So let's connect this to the output here, and after that we can drop a UV texture maybe for now, and after this let's drop another wrangle, and inside the wrangle let's create an island attribute actually to differentiate between detail islands and those main parts that are created in the main loop. So let's create an attribute called integer island, and let's make it equal to detail first input iteration, like this. And now we need to create the input for that. So let's click for each begin one, and here we need to create meta import node, and we can connect this node to the second input, like this. Now let's go back to our p length attribute right here, and let's actually change it to the new name, so p length max, and let's change the node name to max as well. And now we are going to reference this attribute in the uniform scale parameter. So we are going to take the detail attribute from node max, and we are going to take the p length max attribute, and let's multiply it by 1.1. It's kind of important because if you won't do this, you can have some issues. Your setup will not even cook probably in some circumstances. Now let's jump to poly extrude node and let's change the extrusion mode to point normal. And this will automatically update the second poly extrude because it's already referenced. So we can go down and let's connect this to the end of the loop and let's display how it actually looks like. So this is how it looks like after the cook, and I think it already works as it should. So now we have this pose transformed attribute that you can see here, and if you drop a wrangle here and you change position to viat pose transformed like this, you can see that we have this dried surface already. So we are going to lerp between this state and this one based on some parameters. So let's delete this and let's create a float. Let's call it duration min, and let's make it equal to channel duration min. And let's also create a max duration, so float duration max channel duration max. And let's also create a start float. Float start equals random number from maybe island, and let's multiply this by duration min. And let's also create a float end, and here maybe let's open the braces, and here we need a random number from I at island multiplied by duration max, and let's maybe add duration max to it multiplied by 0.4. And after this let's create some offset, so kind of delay when this all starts. So frame offset equals, I will make it 15 for now, and let's actually calculate the final duration. So flow duration, and we're going to fit actual frame to that goes from start frame plus frame offset, and it goes to end plus frame offset, and we're going to map it to go from 0 to 1. And now we can update the position. So maybe not. Maybe now let's create an attribute to control the some other stuff. So init lerp. We're going to use it probably in shader. So we're going to fit frame that goes from 0 to frame offset, and we want this to go from 0 to 1. Okay, so now let's drop another wrangle node, and here maybe let's create a random float. So let's call it random, and we're going to fit the value of randomly generated number from island, and we are going to feed this to go from 0.4 to 1. And now let's create a shape interpolation controller. So float shape lerp, let's make it equal to fit value, fit 01 actually, and we're going to fit duration that we already created in this node, and we want to fit it to go from 0 to randomly generated number above. So now we can actually interpolate the position. So v at p equals interpolate between current position and pose transformed, and we're going to use shape lerp float as a driver for this. Now we need to go back to this previous wrangle, and here let's create an duration attribute. So f at duration equals duration, and now we can create the channels, and here for duration min I will set it to 25 and duration max for 70 maybe. And now if you display this last wrangle node, and if you play, you can see how it actually works. And you can of course play with these values. You can make it longer, so maybe 120 like this. I will leave it at 70 for now, but you have the idea. So now we can drop a normal node here, and after this we can maybe add some mountain node. But before this, let's drop a wrangle, and let's actually create an attribute v at p equals, let's make it point to the positive y direction, so 0, 1, 0, and let's use it as a offset attribute here. So up, 0 centered, amplitude something really small, maybe 0.025, and for the element size 1.2, something, you know, really subtle like this. And yeah, now I think we can drop a material node here, and we can create a null, and we can call it out, and I think we're ready to go to create the material. So now we can go to the material palette, and here we can drag the principled shader, and let's jump to the material network, and let's change the name to ground for now. And I think we can go and create some simple camera and light setup for now. So let's start with the camera. I think something like this will work for now. And let's also create a distant light. Maybe something like this. And let's add the environment light as well. And let's change the environment light intensity to 0.3 maybe like this for now. And let's go to the render view, and let's investigate how the light works. Now we of course need to go back and assign this material actually to our geometry. So let's go to the material node, and here let's select our ground material. And now going back to the material, we can we need to deselect the use point color checkbox to work, and we're going to drop a texture node, and here I'm going to choose the dirt 001 base color texture, and I'm going to connect this to the base color input. And in addition to that, I want to scale the UV a little, so I'm going to drop the UV coordinates node, and I'm going to multiply it by some small value, like not multiply, but multiply constant. And let's multiply by 0.15, and let's connect it to the UV channel. And let's also Let's also add some color, so multiply, let's make constant, and let's change this to color like this, and I will make it something like slightly yellow, but really close to white, like this maybe for now. Now let's copy the texture with coordinates, and here let's build some, another setup to mix with this color right here. So let's multiply it by 3 for now. Multiply constant by 3, and let's actually now inverse this. So we need a constant 1, we're going to subtract this, and here let's create an absolute value from that. So now we can make a power of 2, or maybe let's leave it, yeah, 2, and now we can multiply it by yeah, now we can actually import the duration attribute. So let's drop a bind node, and we want a duration that we already created in our geometry, and we are going to fit this value, fit range, to go from maybe 0.3 to 1, and we want to map this to go from 0 to 2, and let's use it as a multiplicator. And now let's also clamp this value here like this for now. And now let's go back here, let's copy the texture and the multiplication node like this, but in UV scale let's change it to 0.5, and let's add a power node, and here let's change the exponent to 0.5 maybe, and let's multiply it with some color. Multiply with the constant color, and let's make it something like this maybe. And now we can actually add a subtract node, and let's connect the clamp to the second input like this. So now we can actually mix between these two like this, and as an interpolator let's use the duration attribute actually. So we can actually copy this and paste it here, and let's connect this to the surface actually. So now let's actually change the roughness, so we can use the duration for that. So we can drop a fit range node, and let's clamp it to go to 0.5, and we want to map it to go from 0.1 to 0.9, and let's connect this to the roughness input. And now you can actually scrap on the timeline and see how it actually affects the material dynamically based on the duration. So you can also go to the displacement tab here and enable texture displacement, and you can use the dirt height maybe, and for the effect scale You can also change it to maybe 0.1. But ideally you want to control this scale by the duration, so let's actually do that. So we can copy and paste the duration here, and we can clamp it to go from 0 to maybe, or maybe instead of a clamp, let's use a fit range. Fit range to go from 0 to maybe 0.4, and let's connect it to displacement, and here scale, displacement texture scale here. So this is how my material actually looks like after playing with the values. So if you're okay with your own setup, now we're ready to go and actually implement the simulation of breaking those islands. So let's go back to the object level. Now let's drop a time shift node, and let's change it maybe to 50 or maybe 55, like this. And it actually depends on the values that we actually used right in this node here. So duration min, duration max. Ideally you should set it to the value like the same as this, so maybe I will set it to 70. And let's actually drop an assemble node to pack our geometry and create name attributes. So create pack geometry, and now let's create an active attribute. So let's drop a wrangle node, and here we can set the active attribute to 0 for now, and let's make actually an ID from ptnum. So id equals add ptnum, and after this we can drop a DOP network finally, and let's dive inside, and here we can drop an RBD packed object node, and here we can take the first context geometry as a geometry source, and let's drop a rigid body solver. Let's connect this to the first input, and let's add some gravity as well as the ground for collision, and we can merge this together. And now if you play this, nothing will happen because we set the active attribute to 0. So we're going to use a SOP solver to change this active attribute dynamically. So let's connect it to the second input here, and let's drop a wrangle here, and let's change the active attribute by condition. So if I at id is less than frame multiplied by 25, we're going to activate the piece. So active equals 1. So now if you play this, you will see that we progressively are activating some pieces. It's like not all of them are activated at once. It's like some of them will activate later, some sooner. We have this kind of randomness. So by playing with these values here, you can actually decide if you want to to go faster or slower. I will leave it at 25 for now, and we can go back here, and we can actually use a DOP import node, and we can copy this and paste it to forced objects here, and we're going to fetch geometry from DOP network like this. So we have this geometry, this simulation, but it it starts from the first frame, and we want this simulation to start as soon as we finish our interpolation step at about frame 55 or so. So to do that, we are going to actually need to switch between these geometries, so we can drop a switch node and let's connect the DOP import to first input and the out from here to the second one, and we can specify the condition here if at frame is less than 70, for example. So now we also need to use a time shift for import at simulation, so we need to shift it by current frame minus 70, and this value should be the same as the one here. And after this, let's unpack the geometry and let's connect it like this. I forgot to add a 1 to this 70 here, so it should be 1 more than the value used in this node here. So now if this is set to 71, I'm going to make the quick flipbook and I will be here in a minute. So this is how my simulation looks like for now in the viewport. And here you can see the final render version with material applied after small tweaks. I hope you learned something new. Thanks for watching and see you again.